Hello, my name is Professor Adrian, and this is episode 13 of the Quadratic series, where we're going to be talking about how to solve quadratics using a method called completing the square. We're going to look at three examples in this video that are on your screen now. So if your homework problems look like these, then this is the correct video for you. If you're looking at these and you're confident that you know how to solve these already using completing the square, these cannot be factored. So completing the square specifically, if you know how to solve these, I recommend going on to the next video. But for everybody else, let's go ahead and jump into it. So before we start looking at the process for completing the square, let's recall what a perfect square trinomial is, because this is going to be important when we look at the process. A perfect square trinomial is when we have a squared plus 2ab plus b squared, and this can get factored into a plus b squared. Okay, so this idea of having a perfect square to make this so that we can factor it easily into this is why we call this method completing the square. We're going to be trying to make this square. Alright, we have our first example. And I'm going to warn you right now that completing the square is a long process. There's multiple steps to it, but we're going to take it one step at a time. And when you start doing these on your own, I want you to take them one step at a time and not combine steps until you get really comfortable with the entire process. Okay, so the first thing we want to do is make sure that a, meaning the number in front of x squared, is 1. Well, in this problem, it's already 1. There's really a 1 right there. So we don't need to do anything. If it wasn't a 1, if it was a 5 or an 8 or whatever, we would have to divide everything by that. Our second step is going to be move c to the other side. So move the constant term without a variable over to the other side. So I'm going to add 5. Leaving us with x squared plus 6x equals 5. Now what I want to do is figure out what number I can put here to turn this into a perfect square trinomial. And the way I'm going to find that number is not through guess and check or anything like that. It's almost like a formula. I'm going to take b, which is this number right here, b, and I'm going to divide it by 2. I'm going to do b divided by 2, or 6 divided by 2, which is 3. And then I'm going to square it. So 3 squared is 9. So b divided by 2 squared gives us this number, and that number is this magic number that's going to go here to make this into a perfect square trinomial. Now I can't just put 9 on one side of the equals. If you think of this equation as a scale, if you add 9 to one side of the scale, it's no longer balanced. So to keep this equation balanced, I need to add 9 to this side of the equation as well. So now that this is a perfect square trinomial, we know that we can factor a perfect square trinomial into a plus b squared. So this should factor into a plus b squared. And the right side is 9 plus 5, which is 14. So what is my a and my b? Well, I know from the formula a plus b squared that the a is the first term and the b is the last term. So looking at this perfect square trinomial, I have an x squared So my A must be x, and my b squared specifically is 9, so my b must be 3. Alright, x plus 3 squared is equal to 14. How am I going to solve this? Remember, we're solving this for x. That is the goal. We are trying to get x equals a number. So how can I get this x by itself? I have an exponent, I'm adding something to it. I need to isolate the x. So the way we're going to isolate it is by getting rid of this squared. We get rid of a squared by taking a square root. Now if I take the square root of something on the left, I need to take the square root of the thing on the right. Alright, so we now have x plus 3 on the left, and on the right I have the square root of 14. And we should know from 2 videos ago that when we take the square root of a number, we get not just the positive answer, we get the negative answer as well. So I'm just going to write this as plus or minus the square root of 14. Now I can isolate this x by just moving the 3 over to the other side. So I can have x is equal to negative 3 plus or minus the square root of 14. Now, if I was able to simplify here, I would, but the square root of 14 cannot be simplified. You might be tempted to put this into a calculator and get a decimal answer, but I would double check with your teacher and see what answer form they want this in. Most will probably just want it in a simplified form, not in a decimal form. Alright, so our answer looks like this. Why does our answer look like this? Why is it not just a whole number? Well, if we got 2 whole numbers, then that would mean that this would be a factorable quadratic. And if this quadratic was factorable, we would have solved it using factoring. But not all quadratics are factorable. So for the ones that are not factorable, we have this additional process that we can do to solve them. So what were the steps? First thing we did is make a equal to 1. The second thing we did was move the c term. The third thing we did was b divided by 2 squared. And let's make another little note. We added that to both sides. The fourth thing we did was factor the perfect squared trinomial. The next thing that we did was take the square root of both sides. Again, we'll make a note so that we remember that this is both sides. And then we isolated the x term. And then the last thing that we would do would be simplify. Alright, so I know it's a lot of steps, but we're going to do them one step at a time, and we have 2 more examples to look at. Our second example, what's the first thing that you notice? A is no longer 1. Let's deal with that. Let's fix it. We're going to divide everything by A. If I divide everything by A, it's going to become 1. I'm going to have x squared. But I need to divide each term by my A value. So I need to divide each term by 2. So if I take this 8x and divide it by 2, I get a 4x. And if I take this 7 and divide it by 2, I get 7 halves. I'm going to keep it as a fraction. We're not going to use decimals. The next step was to move c over to the other side. And then we take our b divided by 2 and we square it to get that magic number that we're going to add to both sides of the equation and end up with that perfect square trinomial. So 4 divided by 2 squared is 2 squared, or 4. So I'm adding 4 to both sides of this equation. Negative 7 halves plus 4. Let's do this over here. Negative 7 halves plus 4. How can I add these? How do we add fractions? Well, recall that in order to add or subtract fractions, we need to have a common denominator. The denominator of this 4 is 1. So to make them have the same denominator, I'm going to multiply the top and bottom by 2. So negative 7 halves plus 8 halves. Now that we have the same denominator of 2, I can just add the numerators. Negative 7 plus 8 is positive 1. So on the right side of this, we have positive 1 half. The left side we know is a perfect square trinomial. So I just need to identify what is my a and my b. So this first term here, x squared, is my a squared. So if x squared is a squared, a must be x. And if 4 is my b squared, then b must be 2. And this is equal to 1 half. Now we can take the square root of both sides, leaving us with x plus 2 equals plus or minus the square root of 1 half. We can then subtract 2 from both sides, giving us x equals negative 2 plus or minus the square root of 1 half. Now we have to simplify. We cannot have the square root of a fraction because that's going to mean that we have a square root or a radical in the denominator. So let's look at what this, we'll do some more side work. Square root of 1 half is, that means I have the square root of 1 over the square root of 2. Square root of 1 is just 1 over the square root of 2. I cannot have this square root in the bottom, so how do we deal with it? Well, we multiply the top and bottom by it. We rationalize the denominator. In doing this, we get the square root of 2 over 2. It is now rationalized, so we can write our final answer that x is equal to negative 2 plus or minus the square root of 2 over 2. Alright, we have one final example to look at, and this is going to be the hardest of the 3 examples. Alright, I don't like using that word. The most involved of the 3 examples. But we're going to do it in the same exact way that we've done the previous 2. I'm going to start by dividing everything by my a to make that a 1. So x squared minus 4x over 3 plus 12 over 3 is 4 is equal to 0. I'm then going to move my c term over to the other side. X squared minus 4 thirds x equals negative 4. Now I need to take my b term and divide it by 2. And then square it to get that magic number. But my b term is negative 4 thirds. How am I going to take a fraction and divide it by 2? Well, taking a fraction and dividing it by 2 is the same thing as taking a fraction and multiplying it by 1 half. Multiplying fractions is easy. We just multiply straight across the top, straight across the bottom. So multiplying the numerators, we get negative 4, and the denominators, we get positive 6. And before I even square this, I hope that we can identify that this can be simplified, and by simplifying it now, we're going to make our numbers smaller and easier to work with for the rest of the problem. So let's do that. This can be simplified into negative 2 thirds squared. So negative 2 squared gives us positive 4, and 3 squared gives us positive 9. This 4/9 is the number that I need to add to both sides of my equation. On the left, we know that this is a perfect square trinomial, so it's going to factor into something very nicely. My a is x, and it's always x if we've done this correctly to make this a equal to 1. My b, now that I have a fraction, is a little bit harder to identify. The way I can easily identify what my term here should be is by looking at my b divided by 2 squared. Whatever b divided by 2 is, in this case negative 2 thirds, is what the b term in your factored version of the perfect square trinomial is. So over here I had a negative 2 thirds before I squared it. That's what's going to come over here every time. And this is equal to negative 4 plus 4 over 9. So we need to turn this into a fraction with a denominator of 9 so that we can combine them. And we do that by multiplying the top and bottom by 9. So negative 36 over 9 plus 4 over 9 is going to give us negative 32 over 9. We then take the square root of both sides. The left will leave us with x minus 2 thirds equals negative 32 over 9. Now I can move this 2 thirds over here. Right? We can isolate this. X equals negative 2 thirds plus or minus the square root of negative 32 over 9. We cannot do, should know this from a couple videos ago, the square root of a negative number. So although we've essentially solved this and gotten an answer, this negative here means that we don't get any real solutions. So we've done all this work to show that there is no real solutions. Alright, that was the third and final example. I know that this one was this episode is quite a bit longer than the others, but I really hope that the process that I laid out, the step-by-steps, are very helpful to you, and hopefully make this what is normally for my students a step up in difficulty compared to what we've done. I hope this video makes it a little bit better for you and a little bit easier to understand. So if this video helped you, consider giving it a like. If you still have any questions, consider commenting. I'm very active down there, and we'll try to answer any questions that you might have. And maybe consider subscribing for more math lessons similar to this one. All right, thanks, and we'll see you in the next one.